Snowpark Python is a powerful framework that allows you to run Python code directly within Snowflake's secure data cloud environment. This eliminates data movement, which traditionally required extracting data from Snowflake to your local environment or other systems. With Snowpark, you bring your Python code directly to where the data lives in Snowflake's secure infrastructure. There are several key benefits to using Snowpark Python. First, it eliminates the need to move data out of Snowflake, which reduces costs associated with data egress and storage. Second, it enhances security by keeping sensitive data within Snowflake's secure environment, compliant with regulations like GDPR. Third, Snowpark enables scalable data transformations, machine learning model building, and data pipeline creation all within Snowflake's infrastructure. Finally, it seamlessly integrates with popular AI and ML libraries, allowing you to train and deploy models without data movement. Snowpark Python integrates seamlessly into Snowflake's broader data ecosystem, as shown in this architecture diagram. It works with components like SnowPipe for data ingestion, Iceberg tables for storage, and enables connections to ML platforms and external functions. In summary, Snowpark Python allows you to run Python code directly in Snowflake, bringing your computations to the data. This approach reduces costs, enhances security, and enables powerful data science workflows within a scalable cloud environment. Snowpark Python centers around two core concepts: data frames and user-defined functions. Data frames offer a familiar pandas-like interface for working with Snowflake data, allowing operations like filtering and joining directly on tables. Here's an example of creating and filtering a data frame using Snowpark's API. Data frames can handle large datasets efficiently. Watch the row count grow as we process data. User-defined functions let you write custom Python logic that runs inside Snowflake, enabling parallel processing for better performance. UDFs are registered and executed within Snowflake's engine. Here's a simple example function. UDFs can be executed many times in parallel. Notice the execution count increasing as processing occurs. These concepts work together in Snowflake's data processing ecosystem, as shown in this overview. To get started with Snowpark Python, you'll need two main prerequisites: a Snowflake account and a Python environment. Next, install the Snowpark Python library using pip. Open your terminal and run the command shown. Finally, configure your Snowflake connection details. You'll need your account identifier, username, password, and specify your role, warehouse, and database for authentication. To begin working with Snowpark Python, you need to establish a session. This connection acts as your gateway to interact with Snowflake data using Python. You provide your Snowflake credentials to authenticate. This includes your account URL, username, password, and role. For better security, store these in environment variables rather than directly in your code. Here's how to create a session using the session builder. Configure it with your connection parameters and call create. The session object enables all your interactions with Snowflake data. Once established, this session serves as your secure gateway to Snowflake, allowing you to work with data through Python without moving it out of the cloud. Data frames are the fundamental building blocks in Snowpark Python. They allow you to work with data using familiar pandas-style operations, but with all processing happening directly in Snowflake's secure and scalable environment. To create a data frame, use the session.table method to reference an existing Snowflake table. This creates a lazy evaluated data frame that represents the table's data. Filtering allows you to select rows based on conditions. Use the filter method with column references to create subsets of your data. This operation is pushed down to Snowflake for efficient execution. Joining combines data from multiple data frames based on matching columns. Snowpark supports various join types like inner, left, and right joins, all executed efficiently within Snowflake. Aggregation combines data using functions like sum, count, and average. Use group by to organize data by categories, then apply aggregation functions for summary statistics. The key advantage of Snowpark DataFrames is push-down execution. Instead of moving data to your local machine, all operations run directly in Snowflake, providing better performance and security. While the DataFrame API in Snowpark closely mirrors Pandas, the key difference is execution location. Pandas runs on your local machine, while Snowpark DataFrames execute within Snowflake's cloud infrastructure. User-defined functions, or UDFs, allow you to create custom Python functions that run directly within Snowflake. There are three main types. Scalar UDFs operate on individual rows, tabular UDFs work with groups of rows, and vectorized UDFs are optimized for handling large datasets efficiently. To create a UDF, you start by writing your Python function. This image shows how the create function statement links your Python code to a SQL function name within Snowflake. Here's a simple example of a scalar UDF that multiplies two integers. The function takes inputs and returns their product, and can be called in SQL queries just like built-in functions. Let's create a custom Python function. This function calculates the area of a rectangle by multiplying length and width. To make your Python function available as a SQL function in Snowflake, register it using session.udf.register. This creates the calculate rectangle area function that can be called in SQL queries. This visual guide shows the process of creating a Python UDF in Snowflake and accessing data from tables, highlighting the key steps involved. This comprehensive guide provides all the details you need for creating Python UDFs in Snowflake using Snowpark, from basic setup to advanced usage. Snowpark is increasingly used for end-to-end machine learning pipelines, integrating seamlessly with popular tools like scikit-learn, TensorFlow, and PyTorch. This integration allows data scientists to train and deploy models directly within Snowflake's secure environment, without needing to move data. The shift towards Snowflake's serverless compute reduces operational overhead and enables autoscaling for variable workloads. As of 2025, 40% of Snowpark workloads involve ML tasks, demonstrating the growing adoption of these capabilities. When working with Snowpark Python, security should always be your top priority. Let's explore key security considerations and best practices to protect your data and ensure compliance. Always store your Snowflake credentials securely using environment variables. Never hardcode sensitive information like account details, usernames, or passwords directly in your Python code. Instead, use environment variables that can be set outside your application. This prevents accidental exposure in version control systems. For authentication, consider OAuth tokens or key pair authentication for enhanced security. Implement role-based access control by configuring specific roles with appropriate permissions in Snowflake. Assign roles to users based on their job responsibilities and the principle of least privilege. This ensures users only access the data and functions they need. For example, analysts might have read-only access to certain tables, while administrators have full control. Leverage Snowflake's row-level security to control access at the individual row level within tables. This is crucial when different users should see different subsets of data based on their role. Additionally, implement data masking policies that automatically obscure sensitive information like personally identifiable data during query execution. Data remains unmasked at rest, but is protected on the fly. This is particularly important when using Python UDFs that process sensitive data. Maintain compliance with important regulations like GDPR in Europe and CCPA in California. Implement measures such as appointing data protection teams, conducting impact assessments, and honoring user rights to access or delete their data. Snowpark Python supports secure sessions with encryption compliant with HIPAA and other standards. Regular audits and monitoring are essential for ongoing compliance. By implementing these security considerations and best practices, you can build robust, secure, and compliant Snowpark Python applications that protect your data and meet regulatory requirements.